Hello students, let's welcome to our YouTube channel Physics for UG. So in this video we shall discuss a question paper as per the new NEP syllabus, and this is the paper of wave and optics. So let's move to the questions. So let's the first question. I'll give you a few seconds to think about this question and I will answer that after few seconds. So refraction at a plane surface is governed by dash law. So first think about refraction. In refraction there is only a law, that is the Snell's law. You know Snell's law, that is equal to sine I divided by sine R is equal to mu 2 by mu 1, or that mu 2 by mu 1 equal to constant. This is Snell's law, and this law is very crucial during a study of refraction. So refraction has basically two laws. This is the second law, which is the Snell's law, or sin A by sin R equal to mu 2 by mu 1, and I is the angle of incidence and R is the angle of refraction. So let's move to the next question. Dispersion occurs because the refractive index of a material depends on the dash of light. So dispersion is basically the splitting of light inside a prism. Whenever white light passes, then it will split into 7 colors: BQ, violet, indigo, blue, green, yellow, orange, red, and that is the dispersion process. And it occurs because of refractive index of a material depends on the dash of light. And refractive index, remember, refractive index mu depends on wavelength of light. How it depends upon? It depends as inversely proportional. So mu proportional 1 by lambda. So this is the basically the cause of dispersion, and it occurs because this refractive index of a material depends on wavelength of light. So next, see, Ramstein eyepiece is designed by placing the field lens and eye lens at a distance of dash the sum of their focal lengths. So in the Ramstein eyepiece there are two lenses, that is field lens and eye lens, and each have focal length f each has focal length ff, and the distance between the two lenses, this is the Ramstein eyepiece. Let's look at the figure. This is the Ramstein eyepiece, and the distance between the two lenses is 2f divided by 3, and f is the focal length of each lens. So in the question, look at the question, at a distance of dash the sum of their focal lengths, the sum of their focal lengths will be f plus f equal to 2f, as the distance is 2f by 3. So for that 2f, that will be 1/3. So by multiplying 2f into 1 by 3, we get 2f by 3. So basically look at the question. It is asking the question that what the distance, basically what is the distance between field lens and eye lens. Okay, that is 1/3 of 2f, and 2f is the sum of their focal lengths. So the answer will be 1/3. Next question. The effective focal length of a thick lens depends on the refractive index and dash of the lens. So what is the effective focal length formula for a thick lens? Remember, I am writing the formula 1 by f is equal to mu minus 1 whole into 1 by r1 minus 1 by r2 plus t by r1 r2 into mu minus 1 divided by mu. This is the formula for focal length of a thick lens. Remember, here mu is the refractive index, r1 is the radius of curvature of the first surface, r2 also radius of curvature of the second surface, and t is the thickness of the lens, and mu is the refractive index. So in the question, the effective focal length of a thick lens depends on the refractive index. Definitely the focal length depends on refractive index mu and dash of the lens and thickness of the lens, and in the question that is for thickness of the lens. Also it depends on the radius of curvature, and radius of curvature of the two surfaces of the lens. That will be another answer, but in the question as it is given dash of the lens, so it will be thickness of the lens. And for a thick lens, so what will be the formula modified for thin lens? Suppose for thin lens, then t is equal to 0, thickness will be 0, t is the thickness of the lens, so t will be 0. So what will be the equation? 1 by f is equal to mu minus 1 whole into 1 by r1 minus 1 by r2, because last one will be 0 because this t part will be 0 for a thin lens. Next question is, what is the phase change on the reflection at a denser medium each dash radian? So this is basically the part of interference which is the Stokes treatment. For Stokes treatment, whenever light undergoes reflection at a denser medium, then there is a phase change of pi radian. There is a phase change of pi radian or 180 degree. But the question is in radian, so you have to write answer pi radian. That is the Stokes treatment. This is called Stokes treatment. Next question. In fluorescence biprism, two virtual coherent sources are produced by refraction at the dash surfaces. You know, in fluorescence biprism, there are two prisms which are connected base to base with each other. So the two virtual, this is the source of light S, and this is the image S1, and this is the image S2, and these are the two virtual images. And the images and virtual coherent sources are produced by refraction at the prism refracting surfaces. At the prism refracting surfaces, because these virtual images are formed in the prism and the real image are focused on the screen. There is a screen. So basically fluorescence biprism is a method used to determine the coherent sources, you to obtain the coherent sources. Okay, next F G question G, that is bimetric E, that is G. Sound waves in air are an example of dash waves. Sound waves are actually longitudinal waves. Actually there are two types of waves, one is longitudinal and another transverse. So water wave, light wave are the transverse waves, and the sound wave as well as spring waves are the longitudinal waves. So I have already discussed in another video, that is what the difference between longitudinal and transverse wave. So in longitudinal wave, the particles vibrate in the same direction as the direction of propagation, and in case of transverse wave, the particles vibrate in the direction perpendicular to the direction of propagation. Okay, next question H. The central maximum in a single slit diffraction is dash times wider than the adjacent fringes. Remember, in a single slit pattern, what is the diffraction pattern in a single slit? So this is the bright, this is the bright, and this is the central fringe, and this is the secondary bright, this is secondary maxima. These are the different fringe patterns, and this line is the central line. This is O, but the this part, the angular separation is, this part is lambda by d, and this part is minus lambda by d. What is d? D is the separation of the slit width, separation of the slit. So from minima to minima, the separation is, this point is also lambda by d. So our separation, and this separation, this is actually 2 lambda by d. This is lambda by d, this is 2 lambda by d. The next part is 3 lambda by d. The next is 4 lambda by d. So in this way, so our separation is exactly lambda by d. That is angular separation. So for this central maxima, the central part is here, this is the central maxima. So what is separation? The left side minima, the left side part is minus lambda by d, and the right part is lambda by d. So what is separation? Separation is 2 lambda by d, and the separation is 2 lambda by d, which is actually double the separation of the other maxima. So in the question, the central maximum in single slit diffraction is dash times wider than the adjacent fringes. So than the adjacent by nearby fringes, the slit separation is exactly 2 times. That's 2 times wider than the adjacent fringes. Okay, Let's move to the next question. I. Round of diffraction occurs when both the source and screen are effectively at dash. Normally, diffraction is basically the bending of light around the corners of an obstacle. So diffraction is basically two types. One is Fresnel, another is Fraunhofer. This is Fraunhofer. So in Fresnel diffraction, the source and screen are at finite distances or nearby each other. But in Fraunhofer diffraction, the source and screen are at infinite distances. So in Fraunhofer diffraction occurs when both the source and screen are effectively at infinite distances. That is distances. Okay. Next question. In diffraction by circular aperture, the first minimum occurs where the Bessel function is 0, because in circular aperture cases the diffraction intensity pattern minima occurs when minimum means the dark rings occurs when Bessel function g1x equal to 0, but the diffraction intensity is proportional to j1x by x whole square. This is the intensity of pattern by circular aperture, but for minima condition the Bessel function is 0, that is g1x equal to 0. Okay, let's move to the next question, part 2. What do you mean by coherent length and coherent time, and what is the relation between these two? So what is coherent length, coherent time? So length is basically the distance or the length up to which the wave remains coherent. And what is coherent time? Is the time for which the wave remain as coherent. Do you know what is coherent? Coherent is basically the wave in which the phase difference remains constant with time. Okay, so what is coherent time? It is the average time interval for which the field remains sinusoidal or definite phase exists. That means it is the time up to which the phase remains constant. That means the wave remains as coherent source. That is coherent time. The coherent length, it is the corresponding distance for which the field remains constant or the phase remains constant. That is called coherent time. This is the coherent time and coherent length. What is length? So coherent length is basically the distance up to which the wave remains coherent. Okay, what is the relation between them? So relation, if coherent length we signify as L and coherent time as T, then coherent length is equal to coherent time into C, because C is the speed of light. So this is the exact formula, distance equal to speed in time. So L is the coherent length, T is the coherent time, and C is the speed of light. So coherent length equal to coherent time into speed of light. Okay, next is matrix formulation. Mention the matrix formulation of geometrical optics. So this matrix formulation you might have studied that matrix formulation. I am just briefing it. By taking two sets of equation, that is x1, suppose x1 equal to ay1 plus by2 and x2 equal to cy1 plus dy2, and by writing the matrix format it will be x1 x2 is equal to a b c d in matrix format, and then y1 and y2. This is the matrix formulation of geometrical, and by this way you can explain the matrix formulation in geometrical optics. So I'm discussing only, I'm giving the hints only for the questions. So what are the phase velocity and group velocity? Write down the relation among them for a dispersive medium. This is a very important question, and this question is being asked in many exams. So what is group velocity and what is phase velocity? Remember, the group velocity is basically, the group velocity is equal to d omega by dk, and phase velocity is equal to omega by k. Now we have to find the relation between these two. So how to find the relation? Okay, remember, so what is the relation? That omega is equal to, that implies what will be omega equal to vp into k. So put that omega here, and we use k because k is equal to 2 pi by lambda, and we use k equal to pi by lambda, and by using this information we can find Vg is equal to Vp minus lambda dVp by d lambda by using simple derivative technique. So Vg equal to Vp minus lambda dVp by d lambda. This is the relationship between phase velocity and group velocity, and Vg is the group velocity and Vp is the phase velocity, and lambda is the wavelength of light. Okay, next question D. A particle executes SHM given by x equal to 0.24 cos 180t plus 0.23 in its SI units. Find its amplitude, frequency, and period of vibration. So look at the equation. This equation is the same format: x equal to a cos omega t plus phi. This is the normal wave equation solution. X equal to a cos omega t plus phi. What is a? A is the amplitude. So here in the question, amplitude is 0.24. Is a system means 0.24 meter. What is frequency? Look at here. That is cos omega t. What is omega? Omega equal to, in the question, omega equal to 180. So what is omega? Omega equal to 2 pi f is equal to 180. That implies f is equal to 180 by 2 pi, that is Hertz unit. So what is period of vibration? Time period t is equal to 1 by frequency, that is 2 pi by 180 second. So these are the different values of this question. So next is, what are hydrogen fringes? And there are two types of fringes: hydrogen fringes and phasor fringes of equal inclination also. So you can write it, that the direct question. Question F: state and explain the Huygens principle. So Huygens principle basically explains about the wavefront and about the primary wavefront, secondary wavelets. So there are basically two points which explain the Huygens principle. Okay, next question: under what condition circular fringes are formed by Michelson interferometer? So the answer will be when two mirrors are almost perpendicular to each other and are positioned to form a wedge-shaped air gap. When the two mirrors in this setup, when the two mirrors, one mirror is this one and another is this one, when the two mirrors are held perpendicular to each other, then in Michelson interferometer we get a circular fringe. Now next move to the next question. Question number H. Calculate the aperture of the objective of a telescope which may be used to resolve stars separated by 4.9 into 10 to the minus 6 radian for a light of wavelength 600 nanometer. So what is given in the question? In the question, lambda wavelength is equal to 600 nanometer, or that is equal to 600 into 10 to the power minus 9 meter, because 1 nanometer equal to 10 to the power minus 9 meter. So the resolved stars separated by 4.9 into 10 to the power minus 6 radian. So that is the angle d theta is equal to 4.9 into 10 to the power minus 6 radian, that is given. So now we have to find the aperture. Actually the formula is d theta is equal to 1.22 lambda by capital D, and D is the aperture. Actually D is the aperture of this telescope. This is the resolving power and angle, that is the resolution formula. D theta equal 1.22 lambda by D. So we need to find D. So D is equal to 1.22 lambda divided by d theta. Now put the values 1.22 into lambda. Lambda is 600 into 10 to the power minus 9 divided by d theta. D theta is basically 4.9 into 10 to the power minus 6. So all are SI systems, so you can use the value and calculate the data and you can get the answer. Now let's move to the next question. What do you mean by resolving power of grating? So resolving power is basically that is simple definition. Resolving power, go for grating definition. Grating are the multiple slits. Grating are the multiple, so we can easily write this question. Now we shall move to the next part. What are the merits and demerits of parameter eyepiece? So you have to remember merit, demerit of parameter eyepiece, and what are the, is there any lens spherical aberration or any type of achromatism or any type of distortion are present. So you have to write merit, demerit of parameter eyepiece, as well as you have to remember the merit, demerit of Huygens eyepiece. So let's move to the next question. Okay, in question B, the focal length of more convergent lens, of a Huygens eyepiece is 0.5 cm. Calculate the focal length of the eyepiece and locate on a diagram the position of its focal points. So focal length of a more convergent. So basically more convergent means, remember, that is less focal length, because it will converge more whenever there is a lens and it converges more. It converges more means the focal length will be less. If it converges less, then focal length will be more. So more convergent means less focal length. So in Huygens eyepiece there are two lenses used. One is eye lens and another is field lens. So the eye lens part has focal length f and the field lens part has the focal length 3f. So the question it is given that more convergent lens. So more convergent lens means that is the less focal length. Which has less focal length? The less focal length is of eye lens. So focal length of eye lens is 0.5 cm. So at the focal length of the field lens, that is equal to 3 into 0.5 because it is 3f. So 3 into 0.5 is equal to 1.5 cm. So what is actually the question? Look at the question. Calculate the focal length of the eyepiece. That means you have to calculate the effective focal length of the eyepiece, Huygens eyepiece. So what are the formula for effective focal length? Effective focal length f is equal to f1 f2 divided by f1 plus f2 minus t. What is f1? f1 is 3f, f2 is f divided by f1 plus f2, that is 3f plus f minus d. What is the distance between the two lenses? That is equal to 2f. So what the answer? That is equal to 3f square divided by 4f minus 2f, that is equal to 2f. That is equal to 3 by 2f. 3 by 2. What is f? F is 0.5. So f is 0.5. So that is equal to 3 by 2. 3 by 2 into 0.5 is 1 by 2. Basically that is 3 by 4 centimeter, or that is equal to 3 by 4 means 0.5 centimeter. Okay, this is the answer. Now let's move to the next question. Question number C. So a traveling wave has a rating of 500 Hz at 340 meter per second. That means this is the frequency, and this is the velocity. How far will the two positions be from each other if that is not each, that is if the corresponding displacement differ in phase by pi by 2 radian? That means they have a phase difference of phi is equal to pi by 2 radian. So it is actually the question, what is given? F frequency is given and a velocity v is given. Velocity v is also given. So by using this f and v, you can find the wavelength lambda, because lambda is equal to velocity by frequency, because wavelength into frequency is equal to velocity. So by using velocity and frequency, so what will be velocity? That is equal to 340 divided by 500. So by using this data you can find lambda. Okay, then what to do? Let us ask in the question, how far will the two positions be from each other? That means how far from each other means you have to find the path difference, because phase difference is given in the question. So there is a formula that path difference, that is very important formula. Path difference delta phi is equal to 2 pi by lambda into phase difference delta x. So in the question what is asked, you have to find delta x. What is delta x? Delta x is equal to delta phi into lambda divided by 2 pi. What is delta phi? Delta phi is the phase difference, that is pi by 2. So put pi by 2 here. And what is lambda? Lambda you can find by 340 by 500 meter. The 500, that will be lambda. You have to find that lambda by divided by 2 pi. By 2 pi. So pi cancel. There is 2. So that will be equal to, actually that is the lambda divided by 4. So you can find the value of lambda and divided by 4. So this will be the answer. Okay. Now let's move to the next question. Question number D. What will happen if Young's double slit experiment is performed in water? That is a very tricky question, performed in water. So in Young's double slit experiment, the most important thing is the fringe width beta. The fringe width beta is equal to lambda into capital D divided by small d. What is small d? Small d is the distance between the two slits, and what is capital D? Capital D is the distance between the slit and the screen. What is lambda? Lambda is the wavelength and beta is the fringe width. So what is fringe width? Fringe width is basically the distance of separation between two bright fringes or two dark fringes. So what will happen if this setup is performed in water? So normally this is lambda, and that lambda depends upon the refractive index mu. How depends? And a mu proportional to 1 by lambda, because mu depends upon lambda as 1 by lambda. So as lambda increases, mu decreases. So when the experiment is performed in air, so the fringe width will be beta equal to lambda into capital D by small d. This is the formula for air. That means when the setup is totally performed in air medium. So if it is kept in water medium, so what will the formula? That is beta dash is equal to lambda dash into capital D by small d. What is lambda dash? Lambda dash is the wavelength in water, and beta dash is the fringe width inside water. And capital D, small d, these are the physical things. They will not change, because capital D is the separation between the slit and the screen, that will remain constant, and small d is the distance between the two slits, that is also remain constant. So how lambda changes? So exactly lambda dash is equal to lambda by mu. What is lambda by mu? Lambda is the wavelength in air and mu is the refractive index of water. So lambda dash will be modified as lambda by mu, because lambda inversely proportional to the refractive index. So what is the equation? That is equal to lambda into capital D divided by mu into D. So exactly this will be 1 by mu times. So the result will be, look at this. So the result will be beta dash is equal to 1 by mu into beta. That means the fringe width decreases by mu times. That means the new fringe width will be beta prime equal to beta into 1 by mu. So whenever the setup is kept in a medium of more refractive index than air medium, then the fringe width will decreases. Okay, now move to the next question is question number E. Light of wavelength 500 nanometer falls normally on a wedge shaped film of refractive index 1.5, forming fringes that are 2 mm apart. Find the angle of the wedge. So it is given in the question. In the question, the wavelength lambda is given, that is equal to 500 nanometer, which is equal to 500 into 10 to the power minus 9 meter. Okay, next part is on a wave-shaped film of refractive index mu, that is mu equal to 1.5, it is also given, and forming fringes that are 2 mm apart. So fringes apart, that means fringe width, and that is beta. Beta is equal to 2 mm, that is equal to 2 into 10 to the power minus 3 meter, because 1 mm equal to 10 to the power minus 3 millimeter, 10 power minus 3 meter. So what's the formula? The formula is, remember, the fringe width in case of wave-shaped film, the fringe width beta is equal to lambda divided by 2 mu theta. What is theta? Theta is the angle of the wedge. That is, theta is equal to lambda divided by 2 mu beta. Now put the values. Put the values of lambda, put the values of mu refractive index and the beta, then you can find the answer theta. And theta will be, what the value theta, that will be in radian. Okay, now next question. Distinguish between Fresnel's biprism and Lloyd's single mirror. And both the setups are used to determine the coherent sources. So Fresnel biprism basically uses two prisms, and Lloyd's single mirror uses only single mirror, and there is a big difference, and there is I'm just telling briefly. In Lloyd's single mirror, there is a mirror, and you get a dark fringe at the center, and if it's a biprism, there is a bright spot at the center. So there are two or more differences you can write. Now explain the advantages of and fineness of fiber interferometer. You can easily write this one, the advantage and fineness of fiber interferometer. So what is the difference between single slit and double slit diffraction pattern? So let me draw the diffraction pattern briefly. So in single slit, remember, there are three different patterns actually. First, that is YDSE, that is Young double slit experiment. The pattern is basically, this is the double slit pattern. That means all the maxima and all the minima have the same intensity. Okay, and the fringe is also equal. That is the Young double slit experiment pattern. So in case of single slit, what happens? In a single slit, the pattern is like that. This is the pattern of single slit. Okay, now in double slit pattern, this is the mixed pattern. So what will be the pattern in case of double slit? This is the mix of single slit pattern. So this is the single slit pattern. This is a single slit pattern. So double slit pattern is inside there. So how can you blur that one? You have to draw the patterns that will be like this. Inside that, inside this one, there is a maxima, there is minima also. So from this part there is maxima, combiningly maxima and all minima. So in this way you can the exact figure you can find from the book also. I am just giving you, this is the hint. This is the type of pattern in double slit experiment. So in the question it is given that obtain the design of a plane transmission grating capable of resolving a wavelength of 0.7 nanometer at a mean wavelength of 700 nanometer in second-order spectra. So it is given in the question. In the question, the resolving wavelength, that is delta lambda. Delta lambda is equal to 0.7 nanometer. Delta lambda, because that is the resolving wavelength, that is a small change in wavelength. Okay, that can be resolved. And the mean wavelength is lambda is equal to 7 nanometer, and the order of spectra is n is equal to 2, second order spectra. Okay, now The resolving power of grating is defined as lambda divided by delta lambda. So what is lambda? Lambda is equal to 700 nanometer divided by 0.7 nanometer, which is equal to, the answer is equal to 1000. That is equal to 1000. So R is the resolving power of grating is 1000. Now there is another formula. The resolving power is also equal to order n into number of lines in the grating. So basically diffraction grating is basically the multiple number of lines. So R is the resolving power and n is the order spectra, that is the spectra order, and capital N is the number of lines. So what is the number of lines? Number of lines equal to R by N. So what is R? R is equal to 1000 by N. N is number of spectra, that is 2. So answer is equal to 500. So N equal to 500, that means the total number of lines equal to 500. So the design of the plane transmission grating requires a total of 500 lines to resolve a wavelength of 0.7 nanometer at a mean wavelength of 0.7 nanometer at a mean wavelength of 700 nanometer. So this is the number of lines which are required to design a plane transmission grating. So this is the answer. What is next question is, what is Cornus spiral and give it significance. So Cornus spiral is the part of Fresnel's integral. This is the description of Fresnel's integral, and significance it is already written in the already I have made a video regarding this, so you can write it directly. So next comes the part 4, that is these are the long questions. So long questions, and I am just telling, state and explain the Fermat's principle and derive laws of refraction using it. So there are another part, so you have to write the statement, the Fermat principle, and explain it, and then derive the laws of refraction using it. Next is study graphically the superposition of two perpendicular SHMs of different amplitudes and time periods in the ratio 1:1. Discuss the special cases when the phase difference is 0, pi by 2 and pi. This is basically the Lissajous figures. Okay. Next is describe the working of Newton's rings and discuss how it is used to determine the wavelength of monochrome light. Newton's rings and evaluation of wavelength. That means how wavelength can be determined. Okay, next is discuss the problem of diffraction of a single slit. I have already told many times about the single slit pattern. So in single slit and also single slit diffraction pattern and double slit interference pattern. So next is what is zone plate. Explain how a zone plate acts like a convex lens with multiple foci, that is multiple focus points. Find the expression of its focal length, because the focal length of zone plate has multiple values, because it depends upon the order n. So zone plate, and explain how the zone plate behaves like a convex lens. So thank you. This is all about the total questions of Weber optics paper as per the NEP syllabus. Now you can prepare accordingly. Thank you all.